Okay, we're going to do a question now with the antiderivative and working with what we call initial conditions. So as we know, whenever we find an antiderivative, we must always include the constant c after we take the antiderivative. However, if we're given initial conditions, we can actually find out what that constant is. So we're going to take a look at what this type of question can look like here. So for this example here, we want to find the curve that passes through the point 2 comma 0 with the slope of this function dy dx is equal to 4x squared plus 8x. So we actually want to find the curve, which means we want to find the original function with a defined derivative of 4x squared plus 8x. So to find the original function from the derivative, we take the antiderivative. So I'm going to start with dy dx, and you know, that's given as 4x squared plus 8x. So when we take the antiderivative, we have to add 1 to the exponent and then divide by that new exponent. So instead of me writing dy dx, it's now just y, because we are going reverse. And I will write 4, and then I'm going to raise 1 to the exponent for 2, which will give me 3, and then divide by that new exponent, which means we're dividing by 3. With 8x, this is 8x to the power of 1, so I'm going to add 1 to the exponent, which gives me 8x squared, then divide by the new exponent, which is 2. Then, of course, whenever we take the antiderivative, we possibly could have had a constant, so we just call it constant c. So from here, we could simplify. So I have y is equal to 4x cubed over 3 plus 8 over 2 reduces down to 4x squared plus c. Now we want to find the curve that passes through a specific point. And that point was 2 comma 0. So that point, we have an x value of 2 and a corresponding y value of 0. So using this point, I can actually find my, my c value. So that point is what we consider an initial condition. So on the original curve, I know that my y value was 0 when x was equal to 2. So I'm going to let y be equal to 0 and, you know, put 2 in for x. So I get 4 times 2 cubed over 3 plus 4 times 2 squared plus c. Okay, so we're just going to simplify this a little bit. We have equal to 2 cubed is going to give us 8. 8 times 4 is going to give us 32 over 3 plus 4 times 2 squared is just going to give you 16 plus c. So as a result of doing all the work here, we're going to end up getting a c value that's actually going to be a fraction. So that number is going to be c is equal to negative 80 over 3 when you solve for it. Okay, so I now just need to take that c value and just put it into the actual original function, which is the antiderivative. So therefore, the curve that satisfies all those conditions is y is equal to, we have 4x cubed over 3. Then we're going to add 8x. Then we're going to subtract constant c, which we actually now know, which is 80 over 3.